Hello, I'm not sure when we're starting off exactly, but I figured we can go ahead and do a quick introduction. This is Martin Bos, runs christiandefense.org, is it? .com. Does a lot of stuff with password cracking. He's also on the Hack3rcon development team and is a co-organizer for the DerbyCon conference that's coming up. And let's let him up here to give a presentation. Come on.
Thanks, Adrian. I want to thank everybody that presented before me and everybody that presented after me. First of all, it's super cool that there was so much support for this little first-time con here in West Virginia. You got a great lineup of speakers, and I just think it's really awesome that all the people from the security community accepted without hesitation and came down here. Some of us even came as far as Puerto Rico, and I just think it's really cool that everybody stepped up to do this. So obviously my presentation is called Now This Is Really Playing with Power. It started out, I forget what, it started out as the Nintendo one, but somebody said that I might have some problems with stealing Nintendo's slogan. And so what we're going to be talking about is turning a useless hobby into a sophisticated attack vector. Everybody does this, so I guess I will too. My name's Martin. My Twitter name's @PureHate. So I have a small IT business in Louisville, Kentucky. I just do consulting, networking, that kind of stuff. I'm a core developer for Backtrack Linux. The co-founder of a website called christiandefense.com. It's just technical answers for technical people. We try to answer we get emails and posts and whatever. We try to answer any question as easy as how to configure my Outlook account, all the way to as difficult as how to do what we're getting ready to do right here. And I just love security. Here's my disclaimer. I don't crack passwords for a living. I'm not a lawyer. I can't advise you on any of these legal issues. I didn't write this tool, OCL Hashcat, but the developer is a great friend of mine, and he lives in Germany, so I've been presenting on his tool all over the place. And like I said, I'm not an expert on any of this stuff. I've been known to be wrong on many occasions, and I'm just a geek that likes to break stuff. All right, so a lot of people think that password cracking is old and played out. That companies have really strong password policies in place, and that defeats the need for keeping up to date with password cracking. It's not really the case. It's true that companies have put more sophisticated password policies in place, where you got to have numbers, underscores, special characters, that kind of thing, and they've implemented password length. And so what that's done is it's defeated some of the old school password techniques like using Kane or John the Ripper, those kind of tools, because they were all CPU based and they were fairly slow. And so anything under 6 characters, alphanumeric, was fairly easy to break, but that's no longer the case. And so you could spend weeks and weeks, even with a quad core, 8-core desktop CPU, trying to crack one NTLM password. And so this is, in my opinion, password cracking is still really important because it's still the #1 primary way that users authenticate with the system. A lot of high-tech companies have some more technical ways to do things, biometric, tokens, certificates, and that kind of thing. But for the most part, it's still the #1 way that we authenticate. And the problem with passwords is they're thought up by humans. And as we all know, humans are the weakest link in any network. And the other thing about passwords is, like somebody was talking about earlier, people usually use the same password for every account. And likewise, anybody that's the administrator of a network technically uses the same admin password all over the network. And with tools like Metasploit Pro, now we can literally just input that password, set it to scan, and own every box on the network with that password. So that password even is still really important. And so in the last few years, what's happened is we've been able to utilize the cores in a GPU for mathematical computation tasks. And that's manifested in a whole bunch of different ways. Most of the ways are video rendering, protein computation. A lot of research and medical fields have been using these processors, and so some people decided if they could do that, why couldn't we crack passwords with this type of thing? And just to give you a rough estimate of what happens, a normal, everyday CPU might be like a Q6600, a quad core, so it has 4 cores, and yes, it's multi-threaded. However, a GPU like a NVIDIA 295 GTX actually has 260 cores, and so if you can just imagine offsetting those 4-core tasks into 260 cores, and that amplifies your chances pretty well of a successful attack. And I already went over, people reuse their same passwords on the network, and more so all over the internet. My mom uses the same password for everything from the bank to Gmail, and she doesn't care what I tell her about it. She's still going to do it. And so that's kind of the cool thing about cracking passwords is if you crack one person's password, you usually have access to almost everything they have. All right, so what I can hack with my graphics card? Yes, you can. There's actually 3 kinds of programming languages that have to do with graphics cards. The original one was CUDA, which was put out by NVIDIA, and then ATI, not to ever be outdone by NVIDIA, quickly followed up with their stream processing. And then what happened is there was so much difference in the community and the code wasn't compatible. Everybody complained, and they said we would like to have something that runs on both, so that we could either have ATI servers or we could have NVIDIA servers. And so OpenCL was born. OpenCL can run on either architecture. And so that's what we're going to be looking at today is OpenCL. Like I said, this can make the difference between 4 to 8 cores versus 260 cores. And using GPUs is way cheaper than any distributed systems. I don't know if anybody uses the cloud, but I did a little bit of testing, and to use 400 CPUs in the cloud costs about $10 or $15 for like 17 minutes or something like that. And I could do the same thing with one 295 GTX graphics card for free, basically, minus the price of the card. But all right, so this opens up a whole new group of attackers to networking, because there are a lot of video cards out there. Everybody's got one that games, and so a lot of people just get, like a lot of people are just interested in breaking web, just because they might have the type of wireless card in their laptop that they need, so they experiment with it. Next thing you know, they're breaking into some networks. Next thing you know, they're causing trouble, and next thing you know, networks are down. And this is kind of the same thing with graphics cards. People get interested in this kind of stuff, and so in my opinion, it opens up a new threat. Anyway, and so with this kind of technology, passwords that are less than 10 characters at all are basically useless, which we're going to see here in a minute. The problem with password policies, although it's more effective than letting the users think up their own passwords, the real problem with policies is that, and this is what I'm going to try to demonstrate today, is that the new attack vector is patterns. And it's been shown, and we're going to try to prove that today, that people in the same company or people in the same environment or people on the same website will utilize passwords, and it will manifest itself in patterns. Like, for example, I had another presentation. I was going to show this too, but I didn't. I'll just run through it briefly. I had another presentation where I showed downloading a company's entire website. We'll pick on Humana since they're from Louisville. You could actually download every single website from Humana, all their sister sites, and you could combine it all together. And then in Backtrack, there's a tool written called wid.perl, a Perl script, and it will actually parse all those HTML, JPEG, all those files, and it will create a word list. And you can use that type of attack against a company and really increase your chances, because when people are creating their passwords, they'll look around and they'll see something on the wall or something that has to do with their company or something on their desk that reminds them of what they made their password. And so a lot of times that can be something that has to do with the company. And so some of the patterns that we found make it really easy to break passwords. And really, in my opinion, any password that's not hashed and salted is really a joke. Windows still refuses to salt their passwords for some reason. Unix has been salting them for a long time. Obviously, they can still be broken, but it takes a little bit more work. All right, so a lot of people say, I use John the Ripper, and it's fast enough. I just put this up here so we can kind of look at some statistics. So just keep this number in your head. Here we're cracking at the most 42 million passwords per second, and this is only on one hash, a single hash that I just put in here, MD5 hash, a loaded up John, and I just ran it with no arguments or anything, so we're at 42 million passwords. So just keep that number in your, and that's actually on a dual Xeon processor computer, so that's still an above average computer. The real number is more like 25 or 30. All right, every presentation's got to have some statistics. So if you want to look, we got some comparisons of OCL Hashcat against some other leading. There are some other GPU crackers, but none of them are as fast. I won't stay on this very long, but this will all be online later if anyone wants to look. But as you can see, like on an ATI HD 5770 OCL Hashcat, that's just one card, runs at 2,392,000,000 keys per second. So that's just one card, which the average gamer has in his computer. And then if you'll remember the slide before, we were looking at like 34 million on a dual Xeon processor. All right, so I'm going to start the demo because it actually takes a little bit longer than an hour, but I got a video if it doesn't finish. So hopefully this is all going to work. I'm a little bit nervous. So what I did for this demo is, I don't know if anybody remembers this, but last year there was a website called rockyou.com, and for one reason or another, I've never actually been on the website, but the way I understand it was when you logged on there, they wanted to use your MySpace or your Facebook password to link you with your profile. So, you know, all social networks want to link each other, and so there was some reason why they wanted MySpace and Facebook passwords, and they promised that they stored them in an encrypted database, and they were hacked, and it turns out that there were 14 million unencrypted Facebook and MySpace passwords in that database. And so obviously that was posted immediately on the internet. And so the reason that I'm using that is because these are all real world passwords that just happened in the past year. So these are current, and I'm not making up these passwords for this demo. So what I'm going to do is, if you look, these are all the plain text passwords in here. Anyway, and so what I'm going to do is I'm going to hash those into MD5s for our presentation. That takes a second. Should have done it in Python. Oh wait, I forgot the most important part. Sorry. So I'm actually not gonna do all 14 million. Sorry. So what I did was I took out a cut of 650,000 of the passwords, and so I have that right here. So as you can see, this is the list that we're going to use for the demo. Sorry. So as you can see, I got 650,000 random passwords that I took out of the list. I use sort with a capital R. The reason I did it beforehand is because it takes about 10 minutes to sort all that stuff. But I assure you, there's 65,000 random passwords. So that's actually what we're going to use for this. All right, so you can see that now I got a whole bunch of MD5 passwords. All right, so what I'm going to do is I'm going to run the first couple of commands, and then I got some slides to explain them. But so the principle of this attack is that these passwords are going to be incorporated with patterns because they're all from the same website. And so what we're going to do, and I'm going to do this with no word list at all. And so the first thing that we're going to do is we're going to run OCL Hashcat, and the remove flag, and I'll explain all these flags, but the remove flag actually, once the hash is cracked, it removes it from the list, so your list gets shorter and it goes faster. And then so we're going to add our list right here, and then what we're going to do is, and this isn't going to make sense yet, but I'm going to explain it in a minute. This is actually how we define all the characters for a brute force. And then OCL Hashcat has a left and a right side, and like I said, I'm going to explain it, and then we're going to output to that to a file called recovered. And this will just get this thing started. So as you can see, this box has 6 NVIDIA 40 GTX cards. They're about $600 a piece, but it's not unfeasible that somebody like me could have this box. So anybody can put this type of thing together. And so what's going on right now is I'm just brute forcing all 6-character passwords. And so as you can see, if you want to look at the speed, I'm going at 7,279.6 million keys per second, which is MD5s. And so as you can see, in about 1 minute, I'm going to crush every 6-character password in this list. 39.6. You can also see, if you want to look where it says recovered, I've already recovered 35,992 of the passwords. And that's kind of the basis for this attack. What I'm going to do is I'm going to take that initial list and I'm going to expand it and I'm going to re-attack. Okay. All right, so I'm just going to go through. This is the example that I just used. I actually didn't use the increment command. The increment just does between 4 and 6, but I found the attack worked just as good with 6, so I'll let that out. But you can use increment. Remove, like I said, removes the hashes from the list once they're cracked. And then M is actually the type of hash. The default is MD5, so I didn't have to give that argument. But OCL Hashcat supports NTLM, salted MD5s, domain cache credentials. There's a whole bunch of algorithms that it supports. So this is not limited to NTLM or ND5. There's probably about 15 or 20. And the newest version of OCL Hashcat that's not out yet supports MD5 crypt, which is pretty cool. Here's all the hashes that are supported. I'm not going to go through them all. SHA1, MD4, NTLM, MySQL. All right, so back to my example. I guess those slides got mixed up. But anyway, so MD5 is the name of our text file. D, you can actually define what kind of GPU devices. Like if you didn't want to use all your GPUs and you wanted your desktop to actually still be working, because when you take all these GPUs, your desktop doesn't work very well. And so you can actually define if you just wanted to use a couple of cards because you were playing a session of WoW or something like that. I don't know. There's actually a nice level from 1 to 160, which you can tone down or up. And then there's actually a GPU loops command, which 1024 is pretty much the default. That has to do with the SPs on the GPU, and it's kind of complicated, so I'm not going to go into that. O is an output file, obviously. The way the char sets work is L is lower. If you look right next to that one, L is lower, U is upper, D is digits, S is special, nothing special there. So when you're making the attack, you can either use one of those, but if you want to use a combination of those, then you need to set a variable. So I'm using one to set the variable to use all 96 characters on the US keyboard. And then after that, there's a left mask and a right mask. And basically, the two masks combined is the number of characters in the password that you're going to crack. And I'll try to explain the mask. The masks is probably the most complicated part. I'll try to explain that a little bit better in a minute. So here's the character sets. There's also, besides the ones that I've spawned, there's actually H, which I've rarely found to be necessary, but it's in there. But you can also set your own custom character set. Like I set hex down here. See how I did the 1, and then I did D for digits, and then I did the first 6 digits of the alphabet, and so that sets me a all hex char set. And so I can either do that in uppercase or lowercase or whatever I wanted to do. So the way the left mask and the right mask works is it takes what's on the left mask and takes what's on the right mask, and it basically combines them together. And so the reason this is cool is because you can put a word list on the left mask and you can put variables on the right mask, and it will append all those digits or variables or whatever you're working with onto every single word in the dictionary. So for example, password.txt is my password list, and I'm appending 2 lowercase digits. Or no, I'm appending all 96 characters in 2 digits to the end. So the reason this is useful is if you happen to know that a company has a password scheme where they have to append 1 or 2 numbers to the end of their passwords, which is common, more common than you think, then you can do your password list in the 2 digits at the end. And so you can make this as simple or as complicated as you want based on some of these patterns that we'll look at. So the attack that we developed is called the fingerprint attack. And like I said, it's used to break large hash word lists from the same company database. And it works on the assumption that people in the same environment will create similar passwords. All right, so how does the attack work? Like I said, we brute force the list up to 5 to 6 characters. And once the small list is made, then what we do is we amplify that list into a bigger list. And then we put those lists on the left mask and the right mask and attack the list again. And we keep doing it over and over and over again. And so let's see what's going on here. Okay, so you can see this is finished. And you can see that I recovered just in 1 minute and 45 seconds, I recovered 88,000 of the passwords. And so what I want to do is, if you look at the list, it comes out with the hash and the password. So the first thing I want to do is I want to cut the hash off of there. And so I want to call that my recovered dictionary. Alright, so now I can look at my recovered dictionary. Oops. It's not 34. Maybe it's 32.
She cut the glimmer.
I know, but it's 34 though. I know it is. Oh, I got it. Okay, I got it. Hold on. Sorry. Technical difficulties. Okay, so now I've got a list of 6. See, these are all the 6 character passwords. So now what I'm going to do is I have an expander. So now what I'm going to do is I'm going to run my expander. I'm just going to show you how the expander works. So if we just echo one word into the expander, we'll see that no less in case it's on. So I just threw the word Facebook in there, and as you can see, it made all those different combinations out of Facebook. It doesn't do leadify or any of that kind of stuff because we found a lot of that stuff to be largely ineffective, but we're thinking about making some switches where we can do some of that stuff. We tested, and this doesn't just make every possibility, but the possibilities that make sense, like vowels next to vowels and that kind of thing. All right, so then the way you run, you just do the expander and you pipe in your dictionary, and then you pipe it out to whatever you want to call it, obviously. I always do EXP, so I know it's the expanded one. All right, so now what I'm going to do with my expanded dictionary, I can take a look at how many are. In there. Just so it turned 88,000 into 2,916,000 words. So that greatly improved my chances. So now what I'm going to do is I'm going to run OCL hashcat again. Give it the N flag, and I want to make sure to remove the old hashes, and I'm going to give it my MD5 list. And then what I'm going to do, remember I was talking about the left and the right mask, what I'm going to do is I'm going to put my dictionary on the left side and the right side. And what that does is it's going to combine every single word in both dictionaries together. So even though my dictionary only had 6 character passwords in it, now when I combine them together, I'm going to be breaking 12 character passwords. And so we want to output that to output recovered. I'll just call that recovered 2. All right. And so you can see there's all kinds of things. You can hit status and see what's going on. So for some reason it's going a little bit slow right now. It's usually quite a bit faster than this, but so we might not have time to watch this finish, but I got a video to show the end of it actually. But as you can see, it's only been 20 seconds and I've already recovered 60,000 more passwords out of the list. And so what happens is we just repeat that process over and over again. We'll let that run for a second. This is just showing you how the expander works. I guess I did that live, so it doesn't really count. So some of the patterns I found in the first time, what happens is every time you expand the list, you create more important patterns. So these patterns don't look like much to begin with. We'll skip that since it's still running. So I guess I already went over most of this, but this is what we're doing with the combination attack, where we put the dictionary on both sides. And this will actually work with any word list. So if you're not doing this combination attack and you're just doing a regular attack, you can just put your regular, whatever word list you like to use on both sides of the attack. And I'm going to show how we do that in a second. I actually did all this live already. But so I expanded the list. And so after the second run, here's some of the patterns that I were getting. And these are starting to look more like passwords. This is after it's been amplified a second time. And somebody doing love equals 0, I mean, like, that's a real life pattern. And so what will happen in the attack is that love equals 0, if it's in the second dictionary, will be appended to basically every single word in the initial dictionary that we started with. So, like, if you had a password like, pinky love or something or whatever equals 0, if pinky was in the first dictionary, it would append love equals 0 and the password would be broken. And so, just to see some live action. So, and you can see, this is how fast the passwords are cracking. And these are pretty complex passwords. I mean, they're not great, but this is only our first actual attack. And so what will happen is, on the second attack, these passwords were almost double in length. But as you can see, we're getting, nothing that's 10 characters is even close to safe. And we've really only been operating for about 10 minutes. So just imagine if somebody has access to your database and can dump all the passwords and they have a couple of weeks. It would be, with this type of setup, it would be absolutely easy to do this.
How much does it cost to build a box that has the level of GPU power that you got here?
This particular box is a little bit that I'm using for this demo. My box that I personally run at home was about $6,000 to build with 4 295 GTXs, Intel, i7 965 Extreme processor, all high-end stuff, 12 gigs of RAM. But it could be done for way cheaper. This box was a little bit over the top. I helped my friend build this box, and so he's letting me use it for the demo. He probably spent about $12,000 on this box, but it's all water cooled.
But if you're a pen test company or a government or anything like that,
for guys like us, that's a lot of money. But for these companies, they spend that on a company lunch, so it's no big deal. You know what I mean? So it would be really easy to build one of these boxes, and you could technically, if you were a company, you could technically internally audit your passwords, in a day, everybody.
Now, I don't do much gaming, but back when I did some, I noticed that it seemed that if you spent 50% as much, you could get something like that was 80% as fast as the best thing.
Yeah,
so that's a good
true.
Sweet spot.
There's quite a few 2 or 3. These cards, for example, are about $600 because they just came out. But there's quite a few cards, that are $200, $300, $400 that support OpenCL and CUDA and a couple other ones. The ATI cards are actually faster. The problem with the ATI cards is they have trouble in multi-GPU environments. We tried 4 ATI cards and we could not get them to work all at the same time improperly. But one ATI 5970, for example, is extremely fast. It's about 3 times as fast as one 480. Their stream technology is just not as good as NVIDIA's CUDA technology, and then the OpenCL just doesn't work as good on ATI. But anyway, I love sheep. And these are real world passwords. What I mean? I got this from Rocky. So.
Was that yours?
Is that your password?
No.
Anyway, so we can go back here and look at this. Obviously, I'm not going to have time to do the second thing, so I'm going to have to break out the video. However, all right, so in theory, you continue to run this. Every time you output the file, see how I appended a 2 to the end? Every time you output the file, you create a new dictionary file because you don't want to create the same patterns over and over again. So you don't want to keep appending to your original list. You want to create new ones, expand it, and reattack and reattack. Okay, so I guess what I'm going to do is. How much time? Yeah, I don't have that much time. So I'm going to have to break out the movie. I'll just skip to the good part. That's not working very well. All right. Can anybody even see that? No. Well, I'll try to narrate.
Anyway, so this is like the initial brute force attack. And so you can see I got about the same amount, 88,000. This is where I'm doing the expander. And I sped this up a little bit, so hopefully it won't be that slow. You always want to do a sort on the expander, otherwise it will create a lot of duplicates. So this is technically right here the attack that we're running right now.
And then so
all right, so here's when that attack finished. As you can see, when I was doing the testing, it only took me 3 minutes to get done with that.
Oh wait, that's the original brute force. I gotta go a little bit farther. All right, so here's where I go to the remove to dictionary.
So here's the attack that I'm currently running, sorry. It took about 25 minutes.
I just put this in there to make the video a little bit more exciting. Alright, so here's the end of the attack.
Like, now you can see on this second attack,
And this isn't even including the first passwords that I cracked, because remember I put them in a different dictionary.
so now I've cracked another 131,000 of the passwords. So plus 88,
I'm at about 200,000
out of 650,000 in 43 minutes.
So now what I'm going to do is I'm just, in the video, we're just doing that exact same thing that I did the first time. Oh wait. I got ahead of myself. But in any case, sorry. But
So I ran the attack again, and this is after the second attack.
and so this,
So you can see that my first removed list had 88,278 in there. My second removed list had 273 million in it, and then you can see the progression. My third removed list had, you can't even see that, 492 more thousand in it. So those are my three lists. I only ran the attack 3 times, and it took me about an hour and 20 minutes total. And so once I add up all those lists, that comes out to be
75% of 650,000 passwords that I cracked in less than an hour. Real world passwords. Oh, whoops. Shit. So, sorry I didn't do the video perfectly. But what I really want to show is... So, what I really wanted to show is that this seems really repetitive. Can it be scripted? This would be a lot easier if I could just run some tool and it would do it. And so we've actually done that. It hasn't been released yet, but it will after this talk. So what we have is just a simple Perl script that we wrote. And so basically all you need to enter in is the your hash file up there, and it's pretty clearly marked. You put in your hash file, your hash mode. If it's not MD5, it's MD5 by default. If your paths are different than these, you'll have to finish all those. And then for this attack, we use dictionaries, going from the smallest to the biggest. And then, so as you can see, what we also do is at the bottom, this is where our stuff is selected from. So not only does it use dictionaries, but it also uses, these 4s are custom char sets. The 1, 2, and 3 are custom char sets that we wrote. This is uppercase, lower, lower, uppercase, lower, just uppercase. And so these things are all grabbed in a random order and put randomly on the left side and the right side. And so we can maybe take a look at how that works. So what we're going to do is we are going to we're going to rehash our list again. And so our original list was called rocku.6500K, and we're going to, we'll put that in something called auto MD5 just so we can show this attack. And so if we take a look, we'll see that all our hashes are in there again. All right, and then so what we'll have to do is we'll have to add our hash list into here. So I called it auto MD5. And then, so that's all the information you need, and you can just execute our new Perl script. Like I said, it's going to be out after this talk. And so it doesn't really look like a whole lot's happening, except for it outputs the number of hashes cracked. And these hashes cracked are actually cumulative. So these are the total numbers. So in 7 seconds, I got 9,000 of them already. And so you can always hit status and see what's going on. For some reason, this box is running a little bit slow. In the beginning, as you saw, it was running at 70-something billion, but I don't know what's going on.
But playing Warcraft on?
Maybe. So anyway, you can see we output the command that's happening. So like, there's our crack dictionary, which is after it's gone through the expander. And then so in this, the way that we've randomly chosen all the variables, instead of having the crack dictionary on both sides like in the original attack, now we can append our own dictionaries to every side, or we can do both cracked, or it basically just goes through all of this kind of stuff. So 15,000 hashes in like a minute. And this will, well, now it's really slowing down. I don't know what's going on. Oh, that was finished. Oh, maybe I lost internet. Oh. And if it ever says 0, that just means that it's spinning up for a new attack. So I don't know what happened. Maybe I killed something. But in any way, you just get that. You should get the picture. This attack will continue to run over and over and over and over and over again. And over the last week, I ran this script on the original list of 14 million passwords. And in the original Rocky list, all 14 million, I set it up. And at the end of 12 hours, I was able to crack 10 million of the 14 million passwords. And it was still going. I just figured that was a big enough number to say that it worked.
Yeah, I would think so.
Whoops. I did that. All right, so this slide, actually, the numbers are not what I just told you, because when I did this test, it was on my box with the 4 295 NVIDIA GTXs. So these numbers are actually from 4 NVIDIA 295 GTXs. I actually redid the test and I didn't fix the slide. So anyway, so see how I cracked 7 million of them in 2 hours, and I was able to crack 10 million of them in about 12 hours, which is about 2/3 of all the passwords on the list. If you want to know where to get any of these tools, they're all available on the hashcat.net site, and they're also all included with Backtrack4, of course. And some thanks. My friend Adam's the one that wrote Hashcat. Deadlin's the one that let me use this box for this demo. Tenacity Solutions for sponsoring all this stuff here. QuestionDefense.com, the best website in the world. And the KY Killer is my best friend. And the Backtrack4 dev team, of course. And does anybody have any questions that I've skipped over?
Any plans for a Mac OS port?
It may run on Mac. I'm not positive until I get one in a week. So I don't know, and technically there probably will be. The problem is that nothing but a Linux server is going to handle that amount of cards. We tried with Windows 7 and it was a giant failure. So OCL Hashcat does run on Windows. You can run it on your laptop. You can do whatever, but if you want to build a server like this, I highly recommend using something with Linux that does not have X. I've actually helped a few companies build these. It's really good for internal password auditing, because even if you have a password policy in place, the problem is that people are going to, you may say, I've been to places where they say you have to have an uppercase character and some numbers, and of course everybody is going to capitalize the first digit of their name, and then they're going to append their birthday or their something birthday, and so if you set those masks where it does the first character only uppercase, then the next 4 to 10 characters lowercase, and then either 1, 2, 3, or 4 digits at the end. I mean, just that attack will crack an insane amount of passwords wherever you go, and so that just works on, and so that's where all this came from, is from those type of patterns. Anybody else?
How do you work with Salt?
Salted work in the same way. You can either, they're just a little bit slower. You can either give it a hash file with hash salt. There's a format, salt hash salt, or whichever. You just choose the proper attack with the M flag, or you can specify a salts file. Like, for example, if you have a whole bunch of root passwords and they're all salted with root, and you don't want to reiterate root every single time with every password, then you can just put root in a salts file and specify that with S, maybe, I think. Anyway, and so that it grabs that salt out of the file each time. But it basically cracks in the same way, it's just a little bit slower. All right, thanks very much.